Hi, 5th grade. So we're going to be doing Module 3, Lesson 11, and we're going to be subtracting fractions exactly the way that we were adding fractions. The only difference is we are now going to be subtracting them instead after we get our equivalent fractions. So you see that we have 1/3 minus 1/5 right now, and both of our denominators do not match, so I need to change them into equivalent fractions so that they do have that same denominator. Now, I'm going to be using some of the tricks I learned from the previous lesson or for some of the lessons in class. And you'll see that since I have two odd numbers right here, 3 and 5, I am going to just multiply by the number on the other side. I'm not going to worry about finding that LCM since 15 is going to be the LCM for these two factors. So I have 1/3, and I'm going to be multiplying that up by 5 since that's the number on the other side. And then I'm going to take 1/5, I'm going to multiply it by 3 since that's the denominator on that side. Then I now have 1/3 times 5/5 minus 1/5 times 3/3. Now what I'm going to do is I'm going to do 1 times 5, which gives me 5, and 3 times 5, which is 15. I will then subtract, and I'll do 1 times 3, which gives me 3, and 5 times 3, which is 15. I now have 5/15 minus 3/15. These are now fractions that I can subtract because they both have a denominator of 15. So I'm going to take a look at my numerators and go ahead and subtract those. So I have 5 minus 3, which gives me 2. And then my denominator will stay the same so that I have a final answer of 2/15. So like I said, it's a very similar process. Pretty much all the steps are the same except that you are going to be eventually subtracting in the end, but pretty much all the other steps you do will be exactly the same. So now let's take a look at another problem. So for this one, we have 3/5 minus 6. So 3/5 minus 1/6. And for this problem, again, we're going to be setting up those parentheses and filling them in with our fractions. So we have 3/5, I'll write 3/5 over here, and then I have 1/6 over here. Now, I'm going to think about what my least common multiple would be. Since there is an even number there, I'm going to go ahead and count it out just to be safe. So when I go to find my LCM, I just list all the factors of 5, 10, or multiples, 5, 10, 15, 20, 25, and 30. And then I'll list out my multiples of 6 as well. So for 6, I have 6, 12, 18, 24, and 30. 30 is going to be our least common multiple because it is the smallest number that matches between both of these rows. So that tells me that I just need to multiply by the number, by the denominator on the other side. So I'm going to take 3/5, I'm going to multiply by 6/6 so that my denominator is 30. And then I'm going to take 1/6, I'm going to multiply that by 5/5, because 6 times 5 would also give me an LCM or denominator of 30. So then we do 3 times 6, which gives me 18, and 5 times 6, which gives me 30. Then we do 1 times 5, which is 5, and 6 times 5, which is 30. So that leaves me with 18/30 minus 5/30. Since I have the same denominator, I can just subtract now. So I have 18 minus 5, which gives me 13/30. Remember, our denominator stays the same for my final answer. Now I know subtraction can be a little bit trickier. So something that you can always do is if you get to this point, 18 minus 5, and you don't know how to subtract horizontally, you can just set it up vertically, up and down, to help you solve it in like a standard algorithm. Because then you could do 8 minus 5, which you know is 3, bring down the 1, and then you would have your final answer. So you could always set this up off to the side to help you solve, to find your correct numerator. All right, we're going to move on to our next problem, and this next one is going to be a little bit trickier because we're going to have two different methods that we can use to help us solve this problem. So I'm going to call this option A, and then eventually option B. So we're going to start off with option A, and what you're going to see is we now have a mixed number, and we're still subtracting, but I have a mixed number. So this changes up our problem just a little bit. So option A, what we're going to do is we're going to take this mixed number and we're going to make it an improper fraction. So to do that, we're going to start with the whole number. So this is important that you know how to identify all the parts of a mixed number. We have the whole number, the denominator, and the numerator. So starting with my whole number, which is 1, I'm going to kind of like think about, I do a little like kind of swooping arrow over here. Oops, sorry, arrow. And I say 1 times 4 is 4. Then I keep kind of going up, and I think about, well, then I did 1 times 4, but now I need to add this answer, so 1 times 4, which is 4, and then I add 4 plus my numerator, and my numerator is 3. So 4 plus 3 is 7. So think of it almost like you're going in a circle, a backwards circle. You start here, you make your way backwards, and you think, okay, I'm going to multiply this first set of numbers, so 1 times 4, and then after that you keep going around backwards to the circle, and you add what's on top. So multiply, then adds that answer. And then after that, we have a numerator of 7, so it's kind of like, we just kind of brought that up to the top. So we have a numerator of 7, but my denominator is going to stay the same. So 1 3/4 is the same thing as 7/4. Another way you can think of this is that if I have the fraction 1 3/4, I know that I have 3/4, but I also know that 1, I can think of that as 4/4 in this situation, and 1/4 plus 3/4 would give me 7/4 as well. So that is another way that you can also think about changing your mixed numbers into a into a improper fraction. And now I know normally I say don't use improper fractions, but in this case it's going to make it a little bit easier for you, because now if you're looking at this problem, you can see that now that I've changed this, I can actually just go ahead and solve my problem right now. And that's exactly what I'm going to do. So this should actually be fifths. So I cannot start solving my problem yet. So for this problem, I have 7/4 minus 3/5. Now I need to find my LCM to help me solve this problem. So just using my number knowledge, I know that the smallest common multiple between these two would just be 20. So I'm going to draw my parentheses out, and I'm going to multiply each of these numbers by the denominator on the other side, so that I can get a denominator of 20. So we have 7/4 times 5 over 5, and then we have 3/5 times 4 over 4, because 4 times 5 will give me 20, and 5 times 4 will also give me 20. Then we do 7 times 5, which is 35, 4 times 5, which is 20, 3 times 4, which is 12, and 5 times 4, which is 20 as well. So now I can actually go ahead and subtract. So I have 35 20ths minus 12 20ths. Now that I have the same denominators, I can now subtract. And for this one, this is another one where if you want to, you can just set up a little standard algorithm to help you solve, because I know subtracting horizontally like that can be a little bit difficult. So 5 minus 2 will give us 3, and 3 minus 1 will give me 2. So I now have a almost final answer, a 23 20ths. Remember, we usually don't like those improper fractions. So since I have a numerator that is larger than my denominator, I'm going to go ahead and change this back into a mixed number. So we're going to use that kind of same strategy we've been using. So we have our little addition problem right here. So I have 20 20ths, because that will create a whole number. And then I have 3 more left to add, and I keep that same denominator. So I have 20 20ths plus 3 20ths. Then 20 20ths will become 1 whole, and then 3 20ths will get attached to that. So our final answer is 1 3 20ths. So that is option A. Option A is where you change your mixed number into an improper fraction and then subtract from there. Now option B is going to be a little bit different. For option B, I'm still going to have the same problem, 1 3/4 minus 3/5. And what I'm going to do is I'm going to kind of leave this whole number off to the sides, and then I am just going to be subtracting 3/4 minus 3/5. So I'm just going to be kind of worrying about this part right here, and then eventually I'll worry about this whole number. So we're still going to be doing this step right here where we create these improper these equivalent fractions. So we're still going to be doing this. So I'm still going to set up my multiplication problem like this. So we're going to have 3/4 times 5 over 5 still, and we're still going to multiply 3/5 times 4 over 4, because I still want that denominator of 20. So then we have 15/20 minus 12/20. And I'm going to bring down this 1, because eventually I'm going to be adding this 1 onto my answer. I should have even written here, actually, so I don't forget about it. So I have this 1 plus that I'm going to keep bringing down until I'm ready to attach it to my final answer. And then I'm going to do 15/20 minus 12/20. Again, if you need to, go ahead and set yourself up that little standard algorithm to help you solve this problem. So 15 minus 12 gives me 3/20. That is a proper fraction, so I'm going to leave it alone. And then this 1 is just going to kind of move down here and get added onto that. And again, my final answer is 1 and 3/20. So the only difference between this problem and this problem is that the whole number just kind of like got pushed off to the side for a bit and then eventually got reattached to my answer, while this one we just change it into an improper fraction and then subtract from there. This method will get possibly easier for you once we get into bigger fractions, or once we get into bigger mixed numbers, or when there's 2 mixed numbers up here. So I would suggest really getting used to this model. It's going to help you out a lot. This one, if you forget to add the mixed number onto your answer, you could come up with some trouble. So I would prefer this one, but if this one makes more sense to you, you can always use this one as well. So those are the 2 methods we can use to solve problems with the mixed numbers. And now we're going to do one more problem. So go ahead and flip your notes over. And for this problem, we are doing 3 3/5 minus 2 1/2. So we're going to be subtracting first, just like all the other problems, our whole numbers. And I'm going to be, again, doing this with option A, and then doing this again with option B. So starting with option A, we're still going to do the subtraction of the whole numbers first. So we have 3 minus 2. And we're going to think of that as 1 3/5 minus 1/2 then. So what I'm going to do, and I always want to make sure that that whole number gets pushed over here, because if I try to say that I'm doing like 3/5 minus 1 1/2, I would get a negative answer. Okay. So then what I'm going to do is I am going to change this again into a mixed, or into an improper fraction. So I'm going to think of this, remember, going in that clockwise manner. So we have 1 times 5, which is 5, and then 5 plus 3, which gives me 8. So I have 8/5, or you can always think of this as, if you have 1 3/5, this 1, you can think of this as 5/5 plus the 3/5, which then also gives you 8/5. So it's kind of like taking that step backwards. So we have 8/5 minus 1/2. And now I can set these up in the parentheses and go ahead and subtract. So we have 8/5 minus 1/2. So we set up our problem just like this. And then when I think about my LCM, I think about, well, what would be the least common multiple between 5 and 2? And by this point, you actually might be starting to get pretty good at this, and you can start doing it in your heads. But if I count out by 5s and then I count out by 2s, I'll see that my least common multiple is 10. So I want to multiply each of these by a number that will give them a denominator of 10. So to do that, I'm just going to multiply 8/5 by 2 over 2. And then I'll just multiply 1/2 by 5 over 5. I now can solve these little mini problems to give myself my equivalent fractions. So 8 times 2 is 16, 5 times 2 is 10, 1 times 5 is 5, and 2 times 5 is also 10. So now I have 16/10 minus 5/10. Since I have the same denominator, I can now subtract. So 16 minus 5 is going to give me 11, and then my denominator will stay the same. This is an improper fraction because I have 11, which is larger than 10, in my numerator. So I'm going to have to change that. So I'm going to create that little addition problem that we've been seeing. So again, kind of like taking this step. So I have 10/10 plus 1/10 because 10 plus 1 will give me 11. So I have 10 tenths plus 1/10, and then when I change 10 tenths into a whole number, that becomes 1 whole, and then I would attach that 1/10. So my final answer is 1 1/10 for this problem. And again, this is option A, where you just take your you take your mixed number, change it into an improper fraction, and then just subtract everything and get your final answer in the end. Now we're going to take a look at option B. And for option B, what we're going to be doing is we are still going to subtract the whole numbers in the first part. So we have 3 minus 2, which gives me 1. And normally I would write it as 1 3/5. But what I'm going to do instead is I'm going to put this 1 plus 3/5 minus a half. And I'm just going to worry first about subtracting 3/5 minus a half. So I have 1 plus, and then in parentheses, 3/5 times, and then I subtract 1/2 times. So we have 3/5 times 2, just like we did over here. And then I have 1/2 times 5. So we have 3 times 2, which gives me 6. 5 times 2, which gives me 10. And then over here I have 1 times 5, which gives me 5, and 2 times 5, which gives me 10. So now it's like I have 1 plus 6/10 minus 5/10. Since these both have the same denominator, I can now subtract. So I have 1 plus 6 minus 5 gives me 1. And then my denominator stay the same. So then I kind of just erase that plus sign. And I'll get, again, that final answer of 1 1/10. So these, again, are just two different ways of solving the same problem. So I can change my mixed number into an improper fraction, or I can just subtract my whole numbers and kind of leave the whole number off to the side until I'm ready to attach it to my answer after I subtract the fraction parts. So when you go to do your U-Try problem today, you're going to have 5 3/4 minus 3 1/6. And for this problem, I want you to subtract your whole numbers first, and then make sure you choose one of your methods. If it helps you, you can do both and see which one works the best for you. Great job today, 5th grade, and good luck on your work.